Hello, everyone. This is Michael Ratajczyk, Program Director and Professor of Business Intelligence and Data Analytics, Artificial Intelligence, etc. And I thought I'd come up with a fun example for you today that you might not think of. And so I'm going to share with you a video game that I've been designing for a little while now. And so what you're going to see on your screen in a minute is what's called a game engine. And you're going to see a lot of pictures, and I'm going to get into this concept of data with you. I'm going to show you a couple of characters, some creatures, some different options. This is a very test environment, but what I'm going to talk about is data and how much data is in video games and how much data you need to think about in your projects as you work on data analytics in your programs and classes. Some of you with a software background will wrap your head around this instantly. But just it might be a cool topic for you to think about if you like games and such. So we'll go ahead here. I will launch the game. And this is going to be what I consider the God level. This is where I do a lot of testing on new concepts. So it's really not really clean because I like to throw new elements in and see how they work well with each other. No different than when you do a regression model and you're trying to study how variables impact each other and how X impacts Y and what happens to the intercept, things like that. So here we go. So you've got this screen here where I've got this guy flying around. He's doing a patrol XY coordinates. I've got all of these enemies and creatures up here that are doing different things. They're all doing things based on artificial intelligence that I've built into the models for these creatures. You'll see them jump occasionally. You'll see certain creatures hatch eggs, produce eggs. Some of them produce other things. When I click on things, it disappears and goes. You got things going up into the sky. You've got rain happening here. So if I click on my weather data, the temperature is 92 degrees Fahrenheit. The wind is 9 to the north, and precipitation is 87 or 87% happening right now. Click off that, and I go into my tools. I can choose my weapon. I can choose my scissors. I can choose my axe, things like that. That's all data. Images, of course, but also data. Now, if I click here on this little scientific instrument for a minute, you see methane, benzene, cadmium, chloride, chromium, dioxin, mercury, sulfur, toluene. Well, if you know anything about methane and how it's produced naturally, this big guy up here is producing a lot of it. And so when it reaches the sky, there's a counter that counts how much methane has been released into the atmosphere. When that methane reaches a certain level, something special happens in the environment. Not too different than how it happens in reality. Okay, so you walk around and you can pick up these little bullets. This is a post-apocalyptic kind of game, so bullets aren't the currency. Now I've got one up here, so that's data, counting it. I can buy things with those units. I've got all this data up here. I'm in God mode right now, so that's why it says I'm pretty much immune to dying here. I've got some inventory. I got 1 and 2, 2, so that's data going into 3 out of 100. When I get to 100, I cannot move my character. In fact, when I get over a certain threshold, you'll see that as a percentage of my speed on my character, I start slowing down. Okay, so that's data as well. Jumping around, how far I can jump, based on circumstances. I've got this little guy following me around. He jumps, he follows me around. He can actually climb on top of things because he himself has been built with artificial intelligence modeling. Forget just the fact that these are as well, but this guy responds to me. Look what happens when I touch this guy. Okay, opens up a store box. Like I said, not really set up yet, but getting there. Goodbye player, so a little text fires off here. So now that you have the core concept of the game, let's talk about creatures. And this is going to drive us home here. So I'll zoom in here on this little creature here. Okay. Now, I want you to look at all of what's called an instance variable. Don't worry about all that. Don't worry about the computer science stuff there. But here's all the data. So in your modeling, wherever you are in your program, you're going to have variables, right? You know, sometimes if it's in Excel, they're on the top row and they're going left to right. Your observations are going down. And you might have a completely different setup in R or Python or something like that. But here's this one unit, so you can consider him an observation, right, as if he's a row of data. What's his base speed? Well, 0.1 pixels per second. Okay. His move direction, he's going left. Object health is 1 unit, so if I whack him with my stick, he will die because my stick can do 1 or 2 units of damage. Not very strong stick, but he's a really weak creature. Harvest time. Now, this is where your data starts coming in, is how many seconds before whatever he produces, whether it's methane or a rock or oil or whatever, how many seconds before he produces that item? Is it ready for harvest? No. How many seconds of that 20 remain? Well, that's because in this situation, I wanted to test his output, so I only put it at 5 seconds. So I didn't have to wait a full 20, but it will reset to 20. I put the 20 up there. The animal's ID, okay, that's administrative. That's an artificial key in this instance, but it could be something like a product number. If we're talking about this creature is number 17, and now we have duplicates, it's always a 17, but his instance number is different. Is he growing? Well, yes, he is, because he's growing. He's going to eventually produce something in 5 seconds. Is he fed? Nope, he's not fed. So perhaps if he gets fed, he can produce a better item or quicker, something like that. Does he lay eggs? No. Does he poop items? No. Does he breathe fire? Crush eggs? What is his stomach size? How much can he eat? Can he pee? Right? Can he defecate? Things like that, right up there. Can he burp oil? Yes. This creature burps out oil. Okay, that's just something that he does. Can he jump? No, he cannot jump. Okay, and many more variables I can create in here. Now, let's look at the NPC here and look at the values. Base speed, unit health, move direction left. Okay, what kind of type is he? Well, he's a merchant that sells weapons. Okay, is he talking to the player right now? No. Why do I have that? Because when the player intersects or collides with the unit, the NPC unit, a special box is supposed to open up, like a greeting or, hey, here are the items I have for sale, want to buy them? Because not only do we use this, but it ties into the NPC type. So we're kind of talking about multi-regression here, or multiple variate, multiple conditions, embedded if statements or nested if statements. If this and this equal this, or if this equals this and this equals this, then do this. Max speed. So what is his max speed? You know, testing out, like right now it has a 15 versus a 16. That's me testing it out here. But ideally, you would never want it to be max speed less than current speed or base speed. That wouldn't make sense. But just look at the difference in number of variables here. So what I want you to think about is, are there other variables? Let's look at this enemy here who's got very similar variable structure. He's an enemy versus NPC versus an animal like a cow or something. He's got very similar variables, right? Now he has an attack cooldown before he can attack again. Is he ready to attack? What's the max attack time? How long does it take for him to attack? 10 seconds before he can attack again. Is he alive? Okay, that's going to be important later. What's his base speed? He's a little faster. Can he jump? All that kind of stuff there. Now, as a game developer and you as a data scientist, you need to think through your models way before you start making them. Okay, that's one of the skills you're just going to have to learn, and you're going to have to tweak it. Even after you run your model, you're going to think, you know what, do I have the right variables? Things like that. So what other variables in this instance could you imagine a creature or character would need? Okay, well, I put together a few here, and I think you can see them. Zoom in a little bit for you. All right, Control plus. There we go. I got some variables here. The name of the creature, the level, the family, So is it an insect? Or sorry, is it like what kind of like family does it have? Is it connected to a knoll or different things? Is it biped, quadruped, arachnid, insect, undead, demon, class, so like profession? Is it a merchant? Is it a soldier? Is it an archer? Is it a miner, a crafter, cook, race? So is this an orc, a human, a troll, things like that? Faction, what kind of country and nationality does it have? Is it a merchant? Yes or no? Armor piercing, does it naturally have armor piercing attacks? Is it armored and is it natural armor, not equipment? Resistant to fire, ice, lightning, etc. All the other elements you could imagine. Acid attacks, plasma attacks, wind attacks. What is the weight of the creature? What is the height? Is it currently wounded? If it's wounded, where is it? Is it the torso? Is it the sword arm? Is it the shield arm? Torso's there twice. Is it in the leg, left or right leg? Is it in the head? What level? So maybe in this instance, instead of saying yes or no, to like instead of like maybe we have a variable for torso, one for sword arm, one for shield, one for leg, one for head. So we got several variables here. So wound, or maybe wound, arm. Let's just see, shield, arm, wound level is a variable. And the answer isn't yes or no, but it's level 1 or level 2 or level 3. And you have a data catalog. So you might learn this in another class, or I know you will. 1 equals this, so we're encoding things here as well. And then, of course, the standard kind of medieval fantasy role play kind of attributes here that, are out there: strength, dexterity, constitution, intelligence, wisdom, charisma, and like honor. How honorable is this creature? Will it fight till the end? Will it cower? Things like that, and such. How many other variables can you think of, right? Like, you don't have to have been an expert in medieval fantasy. Just think of like games like Super Mario Brothers. Like, can it breathe fire? Breathe fire? Just breathe fire. Can it do a jump? Can it jump? Can it do a double jump? Can it swim? Can it climb? Okay, maybe it can climb, but can it climb ladders? Climb rocks? All kinds of possibilities. And my point with sharing this with you is to give you an idea of the length of detail and thought that a best-in-class data scientist, a data engineer needs to go to in order to do a really well-rounded, successful project. Okay? And you can apply this to anything, right? Like if you were going to study the performance of people running a marathon, you would have a lot of variables about each runner. You would have a lot of variables about the weather. You'd have a lot of variables about the road condition, which is different than the weather. You'd have a lot of variables about subsets of the weather, such as, is it sunny out? Is it cloudy? Are there a lot of airplanes? Because noise, what kind of noise levels? It's a well-known fact in football that noise can disrupt a quarterback's performance on a play. People can't hear the count, so the center either gives the ball too early or too late. People jump their side, so you have a flag called, things like that. So what are all the conditions out there? And sometimes you don't have them up front, right? Like sometimes a spreadsheet that your instructor gives you might have that already detailed, but oftentimes in our classes, we expect you're going out to get the data yourself. Okay? Not all of it, but if you feel that weather is important in your model and you're studying Toronto, Canada, Toronto's something that happened in Toronto, you should feel comfortable going to a website to pull the data for Toronto based on weather. Okay? No different than if you're looking up demographic data and you need to go to census.gov or bls.gov and hunt for that data. out there. Because we all know that in your job, you're not going to be given, a rubric. You're not going to be given an instruction manual. You're not going to always be given the data exactly how you need it. You might be given too little, so in other words, not enough data, or too much data, and it could be really noisy. So, in a nutshell, I hope this was helpful in giving you an idea of the expectations of a best-in-class data analyst, but in a fun delivery method here, right? I mean, we don't do game design in our program. This is just a special hobby of mine that allows me to de-stress. I actually sell licenses to a lot of my code, my econometrics and artificial intelligence. This is just a game that I putz around in. Um, but generally speaking, I just showed this to you just to see if this is another way that you might be interested in learning how to do artificial intelligence or data analytics. Think about your modeling in the future. So thanks for listening.